What's going on, guys? This is Matthew Poyle here at Eastern Kentucky University. This is YouTube assignment 2 for Dr. Mullen's Organic Chemistry 361. The topic here today is IR spectroscopy frequencies and skeletal structures of organic compounds. My assignment was to take modafinil, draw out its skeletal structure and its functional groups, and determine the IR spectroscopy frequencies from that. So, like I said, this is modafinil, treats uncontrollable sleepiness due to narcolepsy and sleep apnea by improving wakefulness in daytime subjects. The structure here, C15, H15, NO2S. From this, we can determine that the formal charge is in fact 0. Alright, and as we go through the skeletal structure, we have an amide group here, functional group, as I said, due to this NH2. As we follow this through, we have an N bonded to a carbon here, which is double bonded to an O. And this is a ketone group. We can determine this because of this double bonded O to a C, which branches off to 2 R's, R groups. This comes down here to a C. And here, like I said, this is the skeletal structure. So we have 2 bonds here. We have to have 2 H bonds here to complete this because carbon has to have 4. We come down here to this S. This sulfur right here is double bonded to an oxygen. We can determine this is a thiol group because this sulfur also branches to 2 R groups here. And in this case, these are carbons. As this sulfur comes down to this carbon also branches off to 2 aromatic rings. But before we can determine that, this carbon here has 3 bonds. And as I said, carbon has to have 4. So this carbon here has to have an H bonded to it. Like I said, these are 2 aromatic rings here. The rings at each point have 1 carbon, 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 carbon. And alternatively, these have a double bond, single bond, double bond, single bond. Therefore, like I said, each carbon has to have 4 bonds. And this is the skeletal structure. So each of these have to have a hydrogen coming off of them. And yeah, that's the skeletal structure. So we also had to determine the IR frequencies of these functional groups. So this amide group here, due to this N bonded to 2 H's coming down, has a frequency of 3300 to 5500 on the IR spectroscopy scale. As this comes down to this ketone, this has a frequency of 1705 to 1725 right here. And then I'm going to label this for you. This is 1. This is the ketone right here. Then as we go to this thiol, we have a IR spectroscopy frequency of 2550, which would be starting right here and going to here, be this group. As we go to these aromatic rings here, these have a frequency of 1400 to 1600, and they're both the same because they're both identical aromatic rings. So these are labeled here and here as the 2 aromatic rings. So like I said, this amide is here, the ketone is here, the thiol is right here, and then we have 2 aromatic rings here. And within these aromatic rings, there are alkenes, which are labeled as C to C double bonds, which would be here to here. Then we have alkanes, which would be, like I said, these branch off from a C to an H, respectively. These single bonds are alkanes, which is a C to an H. And that is the skeletal structure, broke down into functional groups and IR spectroscopies of the functional groups. Just a little side note, this C15H15NO2S can be labeled in grams per mole as a molecular weight of 273.3501. And that is modafinil, organic compound in Organic Chemistry 361. I thank you guys, and if you have any questions, please post in the comments below, and I'll do my best at replying as quickly as possible. Thank you, guys.